Right, okay, so good news. We don't have to worry about phase one of this problem because it just says, look, we've got an integral, some function f, and we're not being asked to worry about what that function is or where it came from. Likewise, we don't have to do phase three of the problem because it says do not evaluate. Right, so we're just, the focus of this problem is how do we turn a double integral into a nested integral, and in particular, let's worry about the bounds. Let's think about the domain. The domain is the part of the unit disk that lies in the second quadrant in the xy plane. All right, well, let's draw that. Okay, so there's our domain. Okay, so there we go. Which way do you want to slice? Doesn't really matter, but do you have a preference?
No.
Okay, all right. Let's do y slicing first, just because it tends to be the one that's seems backwards. Right, so let's just to demystify. So we're going to do our y slicing, and y slices look like this. Right, and here's the first one, and then there's more, and then there's the last one there. So, in fact, let me just go ahead and clear that out. Okay. Okay, so there's the first slice, and there's the last slice. Is that cool? Now, we are interested in doing an integral here, so we're going, let me go up here. This is dy, and so I need to know the first and last values of y, and so I need to step one solve for y on this slice here. Conveniently, y is 0. Is that cool?
Yeah.
So 0. Next, now I've got to worry about, well, what is y here? It's 1. Exactly. Oops. Yeah, so y bounds 0 to 1. Okay. All right, now again, we have to focus our attention at this. Nah, I knew I was going to do that. I always leave myself this erasing task that's never. Got it. Okay, cool. I'm just going to have to leave that there. I'm scared I'm going to erase the thing. Okay, so we're going to focus our attention now on a single y slice. I guess I'll leave that in red. Here's a single y slice at some given, fixed, known value of y. And now we're interested in the range of values of x, because we're looking now at the x integral. Okay. So, well, here's the smallest value of x. Here's the largest value of x. And so I just want to find the x coordinates of these 2 points. Well, our process, as usual, is figure out what we know about these points. Well, that point there is on the unit sphere, the unit circle. So I know that. And, oh, good news, I also know what y is.
Wait, what does a y equals y mean again?
It just means that that we know what y is.
Okay.
Y is the value of y that we have fixed and chosen.
Okay.
I mean, it's kind of a sloppy way of indicating that, but I don't know. I find it convenient to write down and, communicative enough. So
is it just positive and negative?
Well, we've got to think about that. Now, that's the temptation to look at this and say, okay, well, then x is plus or minus square root of 1 minus y squared. What this really says is x could be either one of these, but you got to think through which one it is. It's the negative one. You're quite right, because clearly,
and then 0.
Clearly it's negative. So, yeah, that's right. So we're going to get negative square root of 1 minus y squared, and then you're very right that the next one is the x2 bounds are freebie, the x2 is clearly 0. Yeah. Don't forget our integrand is, some given function f, and we don't have to evaluate, and so we're done. You doing okay?
Yeah.
Okay. Any follow-up questions, or everybody happy?
Yeah.